Welcome back to the deep dive. Today we're going to do something a little different.
A little bit.
I want you to imagine we are standing in a lecture hall. Not, not the boring kind with the uncomfortable wooden seats, but a really cool high-tech one with a massive whiteboard behind us.
Okay, I'm with you.
And on that whiteboard, we are going to map out, well, really the future of how the government works.
It sounds ambitious, but I think that's exactly what we're doing. We're looking at a document that is, you could argue, the blueprint for the next decade of public sector technology.
And what is that document?
It's the Australian Government AI Technical Standard, and it's version 1.
Version 1. I love that it says version 1. It's just,
Yeah.
it implies this is the very beginning of a very long journey.
It definitely is. And you really shouldn't let the dry name fool you.
Right.
This isn't just some, formatting guide or a list of fonts to use. This is the instruction manual. And I think our mission today is to act as your guides.
Your instructors, if you will.
Exactly. Your instructors through this admittedly dense government playbook. We're going to explain how the Australian government intends to procure, build, use, and eventually kill off AI systems safely.
And safely really is the operative word there, isn't it?
It has to be.
Because we see these high-level ethical frameworks all the time. Things like AI must be fair or AI must be transparent. And everyone in the room, they nod and they say, yes, absolutely, fairness is good.
Of course. Who's going to argue with fairness?
But then the engineers, they go back to their desks, they open up their code editors, and they have to ask, okay, but how do I actually code fairness? What does transparency look like in a Python script?
That's the disconnect. That is the exact gap this document is trying to bridge. It's the translation layer.
A translation layer. I like that.
It takes those lofty AI ethics principles, which are great, don't get me wrong, but they're abstract, and it translates them into hard technical requirements. It's all about establishing, and this is their phrase, consistent practices across every single government agency.
What I found really interesting right off the bat was the approach they took. They call it an agency-first approach.
Right.
Which, if I'm reading this correctly, basically means, please, for the love of everything holy, do not reinvent the wheel.
That is a perfect summary, precisely. The standard recognizes that government agencies aren't starting from zero here.
No.
They already have frameworks for data governance, for cybersecurity, for procurement, you name it.
All that machinery is already in place.
It is. So this standard isn't trying to tear all that down and start some kind of revolution. It's designed to slot into those existing frameworks. It's about adding that specific AI rigor where it's missing, but without breaking the foundations that are already there.
Okay, so let's look at the roadmap for this deep dive. We're going to follow the structure of the document itself, which is built around the AI system lifecycle.
It's a circle, essentially. It's designed to be a continuous loop.
The circle of life for software. We start with part 1, the basics, defining what we were even talking about. Then we move into the life cycle proper, discover, operate, and finally, retire.
Which sounds a bit ominous. Retire.
It does. It sounds like we're sending the AI to a farm upstate where it can run and play with the other algorithms.
Decommission is the technical term they use, but yes, it's the end of the line for the system.
All right, let's grab our virtual marker and jump into part 1. Basics. We're talking scope, definitions, and audience. I think the most important place to start is defining the subject.
Absolutely.
When this document says AI system, what does it actually mean? Because, my toaster has a smart setting and my toothbrush connects to Bluetooth, but I seriously doubt the Australian government is writing technical standards for my kitchen appliances.
You would hope not, no. The standard actually adopts the OECD definition, which is really the international gold standard right now. It defines an AI system as a machine-based system that, for explicit or implicit objectives, infers from the input it receives to generate outputs.
And those outputs could be anything.
They could be predictions, content, recommendations, or decisions, a whole range of things.
Infers. That seems to be the heavy lifting verb there. That's the word that matters.
It is. That one word is what distinguishes AI from just basic automation, and the document is very, very clear on what is out of scope.
Okay, like what?
Simple robotic process automation, RPA, is explicitly out.
Okay, let's unpack that. RPA, that's a term we hear a lot in the business world. What is it in this context?
Right. So think of RPA as a digital assembly line worker. If you write a script that says, open Excel, take the number from cell A1, open this website, paste it into the box, and click submit. That is RPA.
It's just a macro, A fancy macro.
Exactly. It's a human repeatable script. It does exactly what you tell it to do, step by step. There is no inference. There is no probability. It doesn't think or guess.
So if cell A1 is empty,
The script crashes or stops. It doesn't try to guess what should have been there. That is explicitly out of scope for this standard.
okay, so if that's out, what is in scope?
While systems that use statistical models to make guesses, administrative decision-making systems, any system that could potentially produce discriminatory outcomes. And this one is really notable, publicly available AI tools like ChatGPT or Claude or any of the big ones.
Whoa, okay. That is a massive inclusion. So if a government employee is sitting at their desk and decides to use ChatGPT to help draft a policy memo,
That falls under this standard. It is in scope. That interaction is considered a use of an AI system by the government.
that dramatically changes the landscape then. It means this isn't just for the IT people in the basement building a supercomputer.
Not at all.
It's for anyone with a web browser.
That's right.
Okay, before we go any further, we need to do a quick terminology drill. There are a few key terms in here that we need to get straight so we aren't tripping over them later. First up, hallucination.
Right. So in a human context, that's a medical issue.
Yes.
In an AI context, specifically with generative AI, it refers to the system generating information that is factually incorrect, but presenting it as if it's absolutely true.
So confidence is high, accuracy is 0.
Exactly. It's the confident liar. And for a government agency that relies on accuracy, say, for legal advice or medical guidelines, that is a major, major risk.
You can see why. Okay, next term, bias.
The standard defines this as a systematic difference in treatment. And the word systematic is key. It's not just a glitch or a random error.
It's a pattern.
It's a pattern, yes. It's where certain objects, people, or groups are treated differently than others, consistently.
Okay. Generative AI. We've mentioned it, but let's define it.
These are models that create synthetic content.
Synthetic. So new stuff.
Brand new stuff. Text, images, audio, computer code. It's not just analyzing data that already exists. It's actually making something new from scratch.
And finally, a term that I think is going to be the hero of this entire deep dive. Grounding.
Yes, grounding is in many ways the antidote to hallucination. It means connecting the model to trusted data sources at inference time. So when it's generating an answer, instead of letting the AI just make up an answer from its vast, messy training data, which might be outdated or just plain wrong,
Right.
you force it to look at a specific trusted document, like a piece of legislation, and you say, answer the question using only the information in this text.
I love that. It keeps the AI's feet on the ground, literally.
It does.
Now, who is this document for? You might think technical standard means it's for the IT department, but it seems a lot broader than that.
Much, much broader. The standard identifies several distinct roles, and not all of them are technical.
So who's on the list?
First, you have the AI leaders. The document calls them the accountable officials.
So the senior executives.
These are the people whose name is on the project. They are the ones on the hook if things go wrong, the ones who have to sign the paper and face the music.
Got it. Who's next?
Then you have business leadership. Think product managers, program owners. They're the ones who decide what to build in the first place.
And they need to know this standard. Why?
Because it dictates what is feasible and what is safe. You can't just dream up some amazing AI feature if it completely violates the standard on, say, data privacy or explainability.
And then there's a really interesting one. Civil society.
This is a fascinating inclusion. It explicitly lists the public and advocacy groups.
So us.
Us, essentially. The people who own the data or the people who are impacted by the decisions the AI makes. The standard is for them too, so they have a basis to hold the government accountable.
It gives them the language and the framework to ask the right questions.
Precisely. And finally, you have the oversight bodies. These are the regulators, the auditors, the referees.
The referees. I like that. Okay, that's a great foundation. Let's move to part 2. This section is labeled Whole of AI Life Cycle.
Right.
And I like to think of these as the universal rules. These are the things that apply no matter where you are in the process, whether you're just brainstorming on a napkin or you're about to pull the plug on the whole system.
That's a perfect way to describe it. These are the overarching governance statements that touch every single stage.
So statement 1.
Yeah.
It deals with the operational model.
Mm-hmm.
And it immediately throws some jargon at us. Model ops, ML ops, and LLM ops.
All the ops.
All the ops. Can we break those down? Because to me, and I think to a lot of people, ops usually just means keeping the servers running, keeping the lights on.
And that's where it started. But it's a bit more nuanced with AI. For a long time, we've had DevOps development operations.
Sure.
That's just best practice for building any software. You write code, you test it, you deploy it, you monitor it. But AI is different. In AI, the code might stay exactly the same, but the data changes.
Yeah.
And if the data changes, the model changes, its behavior changes. So you need MLOps machine learning operations. It's a discipline built around managing that entire pipeline of data, training, and deployment.
So it's like DevOps, but with a huge focus on the data pipeline.
A massive focus on the data. And then you've got LLM ops.
The new kid on the block.
The new kid on the block. The standard specifically calls it out because large language models, LLMs, require different handling again. LLMOps focuses on things like prompt engineering.
Wait, prompt engineering is an operations task. I thought that was something the user did.
Well, it can be. But from a system perspective, the core prompt that defines the AI's personality or its rules, that's part of the system's configuration. It has to be managed like code.
I see. So if you change the system prompt from, say, be a helpful assistant to be a strict legal scholar.
The output changes completely. So you need to manage those prompts. You need to version them. You need to test them. You can't just have someone changing on the fly. That's LLMOps.
The standard also mentions the choice of hosting. AS versus size.
Right. Infrastructure as a service versus software as a service.
This feels like the classic build versus buy decision.
It is. It's the trade-off between control and convenience. AS infrastructure as a service gives you maximum control.
So you're renting the raw computing power.
You're renting the servers, the storage, the networking. You control the operating system, the security keys, everything. This is really good for complex, high-risk AI, where you need to be absolutely sure nobody else can see your data or influence the model.
And the other side of the coin? Size.
Software as a service. This is your ChatGPT Enterprise or Microsoft Copilot. It's ready-made, it's easy to use, you can get started in an afternoon.
But the trade-off is control.
You have much less control over the underlying engine. You are renting the capability, not the infrastructure. And the standard says agencies need to make this choice deliberately based on the risk profile of what they're trying to do. It can't just be an afterthought.
Let's move on to statement 3, people capabilities. This was really refreshing to see. It explicitly states that you need a diverse team.
And it's not just talking about diverse backgrounds, though that is vital. It's talking about professional diversity.
It's not just a room full of data scientists.
Exactly. You can't just throw a bunch of data scientists in a room and hope for the best. They know the math, but they don't necessarily know the law or the social context of the problem they're solving. The standard says you need ethics and compliance officers. You need domain experts.
Give me a practical example of a domain expert in this context.
Okay, let's say you are the Department of Agriculture and you're building an AI to detect pests in crops from satellite imagery.
Right.
You need a data scientist to build the image recognition model, sure, but you absolutely 100% need an agronomist, a plant scientist on that team.
To tell you what you're actually looking for.
To tell you what a pest actually looks like, what a healthy crop looks like, what blight looks like, and what the consequences of missing one are. Without the domain expert, the AI is just a piece of technology guessing at pixels.
There's a psychological aspect here, too, that the document brings up. It talks about mitigating automation bias and AI aversion.
These are two sides of the same coin, and they are both about human behavior.
Okay, what's automation bias?
Automation bias is when we trust the machine too much. It's the GPS effect. You follow the GPS directions right into a lake because the machine said turn right.
I've nearly done that.
We all have. In a government context, if a fraud detection system flags a citizen's application, the human caseworker might just click deny without checking the details because they just assume the computer knows best. That's a huge risk.
And AI aversion is the opposite.
It's the exact opposite. It's refusing to trust the system even when it's right, usually because we don't understand it or it feels threatening. It's the, I've been doing this job for 20 years, I don't need a robot telling me what to do problem.
So the team needs to be trained to navigate that middle ground.
Skeptical trust. That's the goal.
Statement 4, auditability. This seems to be tackling the famous black box problem of AI.
It's a direct assault on it. Basically says, show your work. If an AI system makes a decision about a citizen, we need to be able to trace exactly why.
And not just in a general sense.
No, in a very specific sense. Who made the change to the code? Why did they make it? What specific version of the model was used on that specific day to make that specific decision. All of it needs to be logged.
Because if someone appeals a decision 3 years down the line, you can't just say, oh, the algorithm changed, we don't really know anymore.
Exactly. You have to be able to reconstruct the crime scene, so to speak. The standard implies you need to be able to spin up the exact version of the model that existed 3 years ago, feed the same data into it, and prove that you get the same result.
Which is a huge technical challenge, but it leads right into the next point, statement 5, explainability.
They're very closely related. Auditability is about tracing the process. Explainability is about understanding the result.
Okay.
This is a mandate to explain not just the technology in general, how a neural network works, but the specific outputs. Why did this particular input lead to this particular output?
And the explanation has to be understandable.
The standard is very strict here. It says explanations shouldn't be confusing or misleading.
So no computer says no.
Or computer says there is a 0.87 probability of non-compliance. That doesn't mean anything to a layperson.
No.
The explanation needs to be in plain language, tied to the actual factors. Something like, the application was denied because the income verified was below the required threshold of X dollars. Simple, direct, and understandable.
Statement 6 is a big one, managing system bias. Now, the expert notes in the document make a really interesting and nuanced distinction here. They say, not all bias is bad.
That's a crucial nuance, and it shows a lot of maturity in the document. In statistics, the word bias just means a tendency or a weighting. It's not inherently negative.
And in policy, sometimes we actually want bias.
They do. We call them affirmative measures. If we have a program that is specifically designed to help a disadvantaged group, the system should be biased towards helping that group. That's intended bias.
So the goal isn't to eliminate all bias.
No. The goal is to manage problematic bias.
Such as?
Things like outgroup bias, where the model performs poorly for groups that were underrepresented in the training data, or confirmation bias, where it reinforces existing stereotypes, and, critically, any bias that violates Australia's anti-discrimination laws.
So it's not about being woke.
It's about not breaking the law. The standard requires agencies to identify how bias could affect people and processes, and, most importantly, ensure compliance with existing legislation.
Statement 7, version control. We touched on this with auditability, but it gets really granular here.
It does. It says you have to version 3 things: the code, the model, and the training data.
That third one is the kicker, isn't it?
It is. Versioning code is easy. We've had tools like Git for decades, but versioning terabytes of training data, that is a massive engineering challenge.
But it's necessary.
It's absolutely necessary. If you retrain the model on new data, even if the code is identical, it is functionally a new system with new behaviors. The standard also mandates semantic versioning.
Which is a fancy way of saying the version numbers actually have to mean something.
Right.
Not just final V2 for real this time.
Exactly. If the version number jumps from 1.0 to 2.0, that should signal a major, potentially breaking change in its behavior or compatibility. A jump from 1.0 to 1.1 should be a minor update. It communicates intent.
And statement 8, watermarking. This is all about transparency.
It is, and it's becoming incredibly critical with the rise of generative AI. The core principle is simple. If a machine made it, the user should know.
So the standard requires visual watermarks where possible.
Yes, like a little logo in the corner of an AI-generated image, but it also requires hidden watermarks.
Hidden watermarks, what does that mean?
It means embedding information into the file's metadata. The standard specifically mentions the C2PA standard, which stands for the Coalition for Content Provenance and Authenticity.
Okay, what is that?
It's a technical standard for provenance. Think of it like a digital chain of custody. It embeds cryptographically signed information into the file itself that says, this image was created by this model at this time by this agency.
And that stays with the file.
Usually. Even if you crop the image or re-upload it, that metadata can often remain. It allows anyone to independently verify the origin of a piece of content, which is going to be vital for combating misinformation.
Wow. Okay, those are the universal rules. A lot to take in. Now, let's enter the life cycle properly. We're at the starting line, part 3, the design stage, or as the document calls it, the discover phase.
And this is arguably the most important phase.
Why is that?
Because this is where you can stop a bad idea before it costs you millions of dollars and causes real harm.
And that starts with statement 9, pre-work. And the very first question it forces you to ask is,
do you actually need AI?
I love that. Criterion 28 literally requires assessing AI and non-AI alternatives.
It's the boring solution test. Can this problem be solved with a better designed form? Can it be solved with a simple spreadsheet? Can it be solved with a rule-based script that doesn't involve any machine learning?
And if the answer is yes,
Then you should do that.
Mhm.
Don't build an AI. AI is expensive, it's probabilistic, which means it makes mistakes, and it consumes a huge amount of energy.
And speaking of energy, Statement 29 requires assessing the environmental impact: electricity, water, carbon footprint.
This is a really forward-looking requirement. Training a large model is incredibly energy intensive. It creates a ton of heat, which requires enormous amounts of water for cooling in data centers.
And government agencies have net zero targets.
They do. So this standard says you can't ignore the carbon footprint of your compute. You have to be able to justify that the public good delivered by the AI outweighs the environmental cost.
Statement 10, human-centered approach. This feels like the ethical core of the design phase.
It is. It talks about designing for human values, things like autonomy, dignity, and privacy. But my favorite practical requirement in this whole section is the opt-out mechanism.
Tell me about that. What does it mean in practice?
The standard says you should provide channels for users who choose not to use the AI.
Okay.
So imagine a grandmother who's applying for a government rebate. If she doesn't want to talk to the AI chatbot or she doesn't trust it with her information, there must be an alternative path.
Like what?
Can she call a phone line and speak to a human? Can she download a PDF, fill out a paper form, and mail it in? The point is, you cannot force a citizen to subject themselves to an automated decision if there's a viable non-digital alternative.
That is huge.
Yeah.
That preserves human autonomy and dignity.
It does, and it pairs directly with the requirement for human oversight. You have to define in advance the points at which a human must intervene. There needs to be a takeover protocol.
A human in the loop.
Or a human on the loop. There has to be a way for a human pilot to grab the stick and fly the plane if the AI starts heading for a mountain.
Next is Statement 11, safety by design.
This is about embedding safety mechanisms right from the start, not trying to bolt them on at the very end as an afterthought. It also includes things like allowing for calibration at deployment.
What does that mean, calibration?
It means you need to be able to tune the system's sensitivity once it's in the real world. For example, you might need to adjust a fraud detection system's threshold for what it considers suspicious based on real-world feedback.
And Statement 12, success criteria. How do we know if it's even working?
Right. And this warns against the trap of a single metric. It's very easy to say, our goal is 99% accuracy, but that can be dangerously misleading.
How so?
If you optimize only for accuracy, you might accidentally sacrifice fairness. If you optimize only for speed, you might sacrifice safety.
The outline mentions balancing trade-offs, like the difference between false negatives and false positives.
This is a classic dilemma in machine learning, and the standard forces you to confront it. Let's take your cyber attack detection system again. What's worse, a false positive or a false negative?
A false positive is flagging an innocent login as a potential hack.
Right. It might annoy an employee, they might have to do a two-factor authentication check. It's a hassle.
A false negative is letting a real hacker in because you thought their login was innocent.
Which could lead to a catastrophic data breach.
So in that case, the false negative is obviously much, much worse. You'd rather have a few false alarms.
You'd rather be safe than sorry. But now, let's flip the script. What if it's a fraud detection system for welfare payments?
Okay.
A false positive there means mistakenly flagging a legitimate recipient and cutting off their payments, their lifeline. That could be devastating.
Whereas a false negative means a tiny bit of actual fraud might slip through.
Which is not ideal, but it's far less harmful than the false positive. The standard forces you to have this conversation and make that call explicitly during the design phase. You have to decide upfront what kind of failure you are more willing to tolerate.
That's a profound requirement. Okay, moving on to part 4, the data stage, or as we called it, feeding the beast.
Because data is the fuel for any AI system, and Statement 13 talks about the data supply chain. I love this framing. Because data isn't just a static pool you dip into. It flows. It comes from somewhere. It gets processed. It gets stored. It gets consumed, and it eventually gets retired. It has a life.
And like any supply chain, it needs to be clean and well managed.
And ethical. Consent is a huge part of this section. The standard asks, does the proposed use of the data in this AI system align with the original consent given by the people the data belongs to?
So if I gave my data to the health department for a specific research study,
you can't just take that same data and use it to train a tax enforcement bot without asking me first. The purpose matters.
it also talks about archival and destruction. Planning for the death of the data.
Right. It can't just hoard data forever. It's a liability. You need a plan. When is it deleted? How is it securely deleted?
Statement 15 covers transformation and feature engineering. This is the real nitty-gritty of cleaning the data, right?
This is where the data scientists get their hands dirty, handling blank fields, spelling mistakes, and what they call noise. It also covers techniques like binning.
What's binning?
It's where you group specific data points into broader categories. So instead of storing someone's exact age as 27, you might put them in an 1824 or 2530 bin. This can help preserve privacy and also make the model more robust.
It also mentions things like optical character recognition, or OCR.
Yeah, that's a big one in government. Turning all those scanned PDFs of old forms into actual machine-readable text that the AI can understand.
Statement 16 focuses on data quality, which I guess is no surprise. The old saying, garbage in, garbage out.
It's the oldest rule in computing, and it's more true for AI than for anything else. But the standard adds a human element here that I found really poignant. It specifically calls out the work of data labelers.
The people who actually categorize the data to teach the AI.
Exactly. Often, to train an AI to recognize bad things like hate speech or violent content or illegal imagery, a human has to look at thousands of examples of that horrible content first and label it bad.
That sounds like a terrible job.
It can be incredibly traumatic. The standard explicitly mentions the need to protect the mental health and well-being of these data labelers. It acknowledges the human cost of getting that clean data. You can't just treat them as invisible cogs in the machine.
Wow. Statement 19 describes what the outline calls the holy trinity of datasets.
Train, validation, and test. This is fundamental to machine learning.
Okay, can you break down the difference for us?
Of course. Think of it like a student in a math class. The training set is the textbook and all the homework problems. The model studies this data for hours and hours to learn the patterns.
That's where it does its learning.
The validation set is like the practice quiz you take during the semester. You use it to check how you're doing and maybe adjust your study habits. In AI, you use it to tune the model's parameters.
Yeah, the test set.
The test set is the final exam. It is sealed. The model has never seen this data before. You only use it once, at the very end, to get an honest grade on how well the model will perform in the real world.
And the number one rule is keep them separate.
Strict, absolute separation. If you let the model peek at the test data during the training phase, that's called data leakage. It's cheating.
Oh, wow.
Because the model just memorizes the answers. It gives you a false sense of accuracy. Then, when you release it into the real world with truly new data, it fails miserably because it never actually learned the underlying concepts.
For generative AI, it also mentions building contextual data sets for RAG.
Right, and this goes back to our hero concept, grounding. This is the process of curating that clean, trusted set of documents, the context that the AI is allowed to use to look up answers.
Part 5, the train stage. We're actually building the brain now. Statement 20 covers model architecture.
And this brings back that buy versus build decision we talked about earlier. Are you using an off-the-shelf model from a big provider, or are you creating one from scratch?
And the standard has advice on that.
It does. It advises starting small. Simple architectures are easier to debug, easier to explain, and cheaper to run. Don't build a 100-layer neural network if a simple, old-fashioned decision tree will do the job just as well.
Statement 22 talks about creation, tuning, and grounding. This seems to be about setting boundaries.
It is. A key part of training is teaching the AI when it should refuse to answer.
Give me an example.
If the user asks for instructions on how to build a weapon, or asks a question that is totally ambiguous and could be interpreted in a harmful way, the system needs to be trained to say, I can't help with that request. It needs guardrails.
And grounding comes up again.
It's central to the training of modern systems. Using ARG retrieval augmented generation to connect the model to that trusted agency data. It's like giving the AI an open book test, but you control which book it's allowed to read.
Statement 23. Validate and assess. This mentions evaluating for bias during the training process itself.
Yes, not just at the end. You have to check for it constantly. And it also brings up a cool technical detail called model pruning.
Pruning, like a plant.
Exactly like that. Once a model is trained, it's often bloated. It has millions or billions of connections between its artificial neurons, and many of them aren't really doing anything useful. They're just redundant math.
So pruning is...
Pruning is an automated process that finds and cuts out those useless connections. It makes the model smaller, faster, and cheaper to run, often without losing any significant accuracy. It's about efficiency.
Okay, we built the model. Now part 6, the evaluate stage. testing.
This is where things get really tricky with AI. Statement 26 acknowledges that AI testing is hard because AI is probabilistic and non-deterministic.
Which is a fancy way of saying if I ask it the same question twice, I might get two slightly different but equally correct answers.
Precisely. Traditional software testing expects 2 plus 2 to equal 4 every single time. If it equals 4.0001, the test fails.
Yeah.
AI is fuzzier, so the standard suggests new methods, like metamorphic testing.
That sounds like something out of a superhero movie. What on earth is metamorphic testing?
It's a really clever idea. It's about verifying the relations between inputs and outputs, especially when there is no single correct answer.
Okay, I need an example.
Let's say you have an AI that translates text. You give it the English sentence, "the cat is black," and translate it to French. You get "le chat est noir." Now, I don't need to know if that's the only correct translation. Instead, for my test, I translate "le chat est noir" back to English.
And you should get "the cat is black" back again.
Or at least something very close, like "the black cat." I don't need to be a French expert to run this test. I'm testing the logical loop. English to French and back to English should equal the starting point or be semantically equivalent. That's a metamorphic relation.
That is fascinating. So you're testing the consistency of the logic rather than the specific content of the answer.
You've got that.
Statement 28, safety and robustness. This is where adversarial testing comes in.
Or, as the cool kids call it, red teaming.
This is literally hiring people to act like bad guys.
Yes. Their entire job is to try and break the system, to find its weaknesses, to poison the data, to try and trick the chatbot into revealing secrets or saying something offensive or dangerous.
And the philosophy is,
you have to attack your own system before the real attackers do. You need to find the holes and patch them first.
the section also mentions stress testing.
Which is about simulating edge cases in extreme conditions. What happens if 10,000 people try to use the system at the exact same second? Does it crash? Does it slow to a crawl? Does it start making mistakes under pressure? You have to know the breaking points.
Statement 30, consequences. This brings up user acceptance testing, or UAT.
This is about testing with real people. And not just your developers. You need to get diverse groups of actual end users. You put the tool in the hands of the people who will actually use it day to day and just watch them. See if they can break it or if they find it hopelessly confusing.
And it also mentions regression testing.
Which is so important for AI. Because a tiny, seemingly innocent parameter change can cause massive, unpredictable defects. You might fix one bug related to, say, dates, and suddenly the AI forgets how to speak German. You have to constantly retest everything after every single change.
Okay, we're getting close to the finish line of the process. Part 7, the integrate and deploy stages. Going live.
The big moment. Statement 32 talks about continuous integration.
This means what?
It's about automating the entire pipeline. As soon as the developer checks in new code, a series of automated tests kicks off. If a single one of those tests fails, the build stops. It cannot proceed.
And no human can override it and say, it's probably fine.
No, the pipeline is the gatekeeper.
Statement 35, deploy to production. The standard advises a phased rollout.
Yes. Don't just flip a switch and release it to everyone at once. That's a recipe for disaster. You do what's called a canary release.
Canary in the coal mine.
Exactly. You release the new version to just 1% of your user traffic. You watch it closely. If the canary dies, if your error rates spike or the system crashes, you know you have a problem, but you've only impacted 1% of your users. You can roll it back instantly.
And if it survives?
If the canary lives, you gradually increase the traffic, 10%, then 50%, then finally 100%. It's a much safer way to go live.
This section also mentions change management.
Which is just about good record keeping. Documenting why a model was updated. Was it a bug fix? A performance improvement? Was it retrained on new data? You need that paper trail for auditability.
Which brings us to Statement 36, rollback. The big red undo button.
This is critical. If your brand new AI starts acting up in production, maybe it's a holiday and it starts hallucinating wildly because it's seeing data patterns it's never seen before, you need a mechanism to revert to the last stable version immediately.
Not, let me call the developer who's on vacation.
No, it has to be an automated one-click process.
Right.
A big red button that switches all traffic back to the old safe version in seconds.
All right, we're live. But it's not over. Part 8, the monitor stage. Watching the system in the wild, you can't just set it and forget it.
Absolutely not. Statement 37 sets up the monitoring framework, and a key part of that is creating feedback loops.
What does that mean?
It means insights from the live production system need to get back to the developers. If users keep asking a particular question that the AI can't answer, the developers need to know that so they can train the model on that topic for the next version.
Statement 38, ongoing testing. And a really key concept here is AI drift.
This is a fascinating and uniquely AI-related problem. It's the idea that an AI model's performance degrades over time.
But why? The code doesn't rot.
The code doesn't rot, but the world changes.
Give me a real-world example of drift.
Okay, imagine an AI trained to predict home prices using data from 2019. It knows everything about the market, interest rates, seasonal patterns. It's super accurate. Then 2020 happens. COVID hits. Lockdowns, stimulus, supply chain issues, interest rates plummet.
The entire housing market changes overnight.
The AI is now useless. The patterns it learned no longer exist in reality. The real-world data has drifted away from the data it was trained on. You need to constantly monitor for that mismatch, and when the world changes enough, you have to retrain the model.
And it also mentions monitoring human-machine collaboration.
This goes back to automation bias. Are the human operators becoming complacent? Are they just rubber stamping every single one of the AI's decisions without thinking?
And if they are?
If the human approval rate is 100%, that's a huge red flag. It's suspicious. It probably means the humans aren't providing any real oversight.
Yeah.
You need to monitor how the humans are actually interacting with the tool.
And finally, a very practical point. DLP, data loss prevention.
This is about ensuring users don't accidentally feed sensitive agency data into a public model. You really don't want a well-meaning employee pasting a list of citizen tax file numbers into a public chatbot to ask it to format this list nicely. That would be a disaster.
Okay. And that brings us to the final act, part 9, the decommission stage, the end of life. It starts with statement 40.
The plan. Decommissioning isn't just turning it off. You need a formal impact analysis. Who is using this system? What happens to their workflow if it goes away? Do we need to hire more call center staff to replace the chatbot?
And communication is key here. Telling the users the system is retiring.
You have to give them notice, and Statement 41 covers the actual shutdown.
Which involves more than just pulling the plug.
Much more. Securely wiping the hardware, repurposing the computing resources, all the standard IT offboarding.
But there's a catch, isn't there? Statement 41 also says you have to retain compliance records.
This is the idea of zombie AI documentation. You still need to be able to prove what the AI did, even long after it's gone.
Why?
Because if a lawsuit comes up 5 years later regarding a decision that was made by that now decommissioned AI, you still need the logs, you need the version history, you need the data records. You can't just say, sorry, we deleted the server years ago. The accountability outlives the code.
Wow. Okay, let's unpack this whole journey we've been on.
It's a long one.
We've gone from the very first question, do we even need this thing? All the way through to designing it, training it on clean data, red-teaming it for safety, monitoring it for drift as the world changes, and eventually killing it off securely while keeping its records.
It's a comprehensive life cycle. It really does cover everything from cradle to grave.
So, summarizing the big picture here, this standard, it represents a massive shift in thinking. It feels like we are moving away from the old Silicon Valley mantra of move fast and break things.
To a new government mantra of move deliberately and document everything.
That is exactly it. And for government services, that's really the only way you can operate, isn't it? When you're dealing with people's lives, their benefits, their visas, their health records, you simply cannot afford to break things.
No. You need rigor. You need traceability. You need accountability.
It feels like a shift towards maturity. AI isn't a fun new toy anymore. It's being treated as critical public infrastructure.
And this document is the national building code for that infrastructure.
I want to end with a thought that really struck me while reading about the AI accountable official. We are building these incredibly complex, probabilistic, non-deterministic systems that even their creators don't fully understand. And yet, the document, again and again, heavily emphasizes human oversight and human accountability.
It does. At every critical stage, it places the burden squarely on people.
So here's the provocative thought for you, the listener, to take away. In a world of increasing automation, where the machines are doing more and more of the heavy lifting of thinking and deciding, are we, as people, prepared for the increasing weight of responsibility that comes with managing these systems? Because if the machine messes up, it's not the machine that gets fired.
No.
It's the human who signed the paperwork.
And that is the paradox of AI, isn't it? Ideally, it does the work, but we have to keep all of the responsibility.
Something to mull over. Thank you for joining us on this deep dive into the Australian Government AI Technical Standard. We hope you feel a little more informed, a little smarter, and maybe a little more prepared for the future that's being built.
Thanks for listening.
We'll see you next time.